Hey, welcome everyone to the daily practice. So today our focus is the three questions that were posted about 23 hours ago. We have the easy question, the medium question, and the hard question. If you haven't actually joined us, please join us at sdskills.com/slack and join the #leetcode practice channel. All right, with that said, let me resume the screen share and share application window. All right, so did you guys able to see my screen?
Yeah, you can see.
Okay, fantastic, awesome. So the first question that we have is essentially N-ary Postorder traversal of an N-ary tree. Anyone who's who's tried solving this? So it's like we know how it works for a binary tree, but this is just a N-ary tree. Where how would you actually store the children in a binary tree? Anyone? Go ahead, Smita.
Like it's in the form of children, left child and right child, right?
So we do left child and right child. They're actually named children in the case of a binary tree. But in the case of an N-ary tree, there is no left, there is no right. They're just children, right? They're all the children, 1, 2, 3, 4, 5, or whatever. So how would you do post-order traversal in that case? The concept remains the same, right? A post-order traversal is where you traverse all the children before you traverse the parent. And that's pretty much what it is. So the expectation will be that you will be, in this case, you'll actually have to traverse all the child elements. Anyone who's actually written code for this?
So I think it is same thing you can do as a binary, and instead of left and right, in this case, basically we go through all children before we.
That's it. Simple for loop with all the children, right? In a typical post-order traversal, right? There is no concept of like left right and then right left. Like you just transfer. You just have to finish all the children. That's it. So the only catch here is that the input is represented in the level order traversal with null whenever there is nothing. So I think the tree reconstructions is a little bit of a pain. Each group of children is represented by nulls. So essentially, you just have to like reconstructing the tree will be a little bit of a pain. But actually, I don't see any concerns on this question. So anyone here who actually wants to share their code or talk about how they've been doing it? Has anyone solved this?
Yeah, I have solved it.
So go ahead. How did you solve it, Sonia?
Sure. Let me share my screen, or I can explain over here.
I may have to stop share. You can share it. Go ahead.
Okay. So can you see my screen?
Yeah, we can. Go on.
So the thing what I am looking for it is like we need to put like the children's first, but it in a reverse order. So here it should be like the stack. Whenever we need to put something in a stack, it should be in a reverse order. For example, first of all 1, then 4, 2, 3, and then 6 and 5. So that
Go
when
on.
we pop, something, then it should be like how we can pop easily the which is at the top. So based on this, so what I just take a stack and put a node of root, which is 1, and when I pop the 1, I append that on a first place, which is at the 0 place of the result. For example, here my I have a result set, and I have put here 1. Can you see over here where I have say
Yep.
set the result?
They can see you.
Okay. And so now I need to traverse the all the children of those of that node, which are like and my stack now would look like it. My stack would look like this. It should be having 3, 2, and 4.
You push 3 first, then you push 2, then you pushed 4.
Yes. So yeah. So it's the stack. It's having 3, 2, 4. Like it's on a going from downwards to upwards or from left to right. Like 4 is on a top.
Correct.
And now when I again go for it in a stack, now I pop 4. Now I pop 4. Now my 4 is inserted at the 0th position again, which is like here. And then again it would check if there is no children, then it will again go high 2, and now 2 will be inserted at the 0th position. Like it will be in a appending in a reverse direction, I would say. And again 2 is also not having any children, but 3 is there. 3 is having their children. So first of all, 3 will be inserted at 0, and then its children would be like 5 and 6 in a stack.
And then you will pop out the 6 first. Put it there. Pop out the 5 first.
0th position, like it's appending at the left side, not at the right side. So again, pop 5. It will be like 5 over here.
Perfect.
Yeah.
So what? Why did you choose iterative over recursive?
I am looking for iterative, like something like I am comfortable with iterative, I would say. And I know there would be something with a stack I can easily do. So that's why iterative I chose. Like I know there would be a stack option.
No, I understand that. So I think this is an iterative solution, and this is using stack. The only negative part of the solution, which actually makes it a little uncomfortable, is the fact that you have like you're actually you're adding the data from the back. So you're assembling the result in the reverse order. If you and you're processing it in almost the opposite order, right? And then you're putting it in a stack. You're putting it in a essentially what you're doing is the final one is a stack.
Yes.
Even though you're doing an insert first, right? But it's effectively a stack based thing because you're outputting the data in the exact reverse order of which it is required. So it's a little weird because if you wanted to do this for any computation purposes, like for example, if you wanted to do a post-order traversal because you wanted to calculate the cumulative sum of this entire tree, you will not be able to do that because you've already processed 1 before you have processed 3, 2, and 4. Even though in the output you've done it the right way. So while this is actually accurate for this particular question, you may struggle if you're doing this for other reasons. So just be watchful. Do practice the regular stack, regular question, which is where you will be essentially what you are doing is it's a recursive solution, right? You will take the first element, process all its children, you'll recursively call process on the children, and then you will just call the process self essentially, and that's like a 4-line, 5-line code.
Okay. Yeah. So that will also work. I know. Yeah.
That's the easier algorithm. So I think we can definitely move on to the next question at this point. But But this is like a very interesting approach, and this approach works, and
So I
it's
have a
accurate,
question,
and I
like,
think it will work in all cases. Go ahead,
like
Sonia. Sorry.
there is a question like something if we need same question with the pre-order.
Hmm.
So like if we need to print as a pre-order thing.
If it's a pre-order, then I think it's the same, right? You would actually just, instead of doing insert first, you would probably do. I mean, recursion makes it easy. You can just process node, and then you can process the children much easier.
Mm-hmm.
But if you were to do something similar, I would assume you will insert that not in the 0th position, but in the end of it. Anyway.
Add the position or like yeah, simply appending.
Yeah, simply append will work. And the
Yeah.
only other thing that you would do differently is, I think that's it, right? That's it. If you just append at the end, you just pre-order, right?
But I think then I need to append in a stack in a reverse way. Like first of all 4 2 3 instead of 3 2 4. How I am appending. Like my children's would be in a stack should be in a reverse way. Thinking like that. Because then on a pop I'll be getting 3 first. Something like that. So if it's 1, then I know something like if hello. I'm not able to hear you.
I'm there. I can hear you, Sonia.
Okay.
Yeah.
So so it's like if I need to append in a I need to do it that in a pre-order, then it should be like I have written something 1 here,
Mhm.
and then while append in a stack, I should append in reverse direction, which is like 5 2 3, and then if I 4 2 3, sorry, like when I remove 3, it is appended over here, then and then its children's are 6 and 5, then 5 will move and it would be here,
Then instead of stack, you can take a queue.
then 6, yeah, I think I have erased 2 over here, but it's then 2 and then 4, it's like that, like it's simply like, but the only trick is either we can take a queue in here or a stack, like it's up to us. Like queue would also work because we are if we are making it in a queue, then we are pending 3 2 4, then the first one would remove like 3. So instead of stack, I thought because it's a same version of that question, so I have taken stack, so I tried with stack.
Also, the question said iteratively, right? To do it iteratively. Is that the reason why you did it iteratively?
Yeah, maybe one. Yeah, I have taken iteratively also. It's written iteratively as well. Mm-hmm.
Hey, my audio bridge kind of gave out, so I'm just dialing in from my phone. So I was following along what you're saying. So yes, this is good. Just trying to see if there were others who had any other questions on this specific question. We can move on to the next one otherwise. I mean, this approach is fantastic, and this works. And I think you also have, the good thing I like about how you've thought about this is also you're thinking about how do I extend this question in terms of what if it was pre-order versus post-order and things like that. There is no concept of in-order for an N-ary tree because there is no middle, right? It's a little hard to figure out.
Yeah.
Okay. And you can always do level order traversing as well for this one, which is like a simple breadth first search. So in that case, you will just.
Yeah, that's a good approach, an easy approach.
Yeah. All right. If there is no other questions, let's actually switch to question number 2.
I'll stop sharing.
Yes, please. I will share my screen. Question number 2 is the increasing triplet subsequence. Let me just get my screen back. Start share. I'm assuming you guys can see my screen. All right, awesome. So this one is actually, again, I was actually wondering why this was a medium, because the whole idea is that you just have to find numbers which are actually increasing subsequence of length 3. So any thoughts? So if you haven't, if nobody has solved this, take a few minutes, think about the question. You're given an array, unsorted, like 1, 2, 3, 4, 5. Then you just need to make sure that you find 3 numbers which are consecutive, like 1, 2, and 3. Not necessarily consecutive, right? It's a subsequence. So you just have to find 3 numbers which are in increasing subsequence. So if it had been, they didn't give a counter example. So if you had something to the effect of like 1, then like a 9, then 8, 7, then a 10, then there's an increasing subsequence, multiple of them. 1, 9, 10 is an increasing subsequence. 1, 8, 10 is an increasing subsequence. 1, 7, 10 is an increasing subsequence. So you just need to find, so this is not consecutive numbers, but it's just increasing subsequence. Any thoughts? Has anyone tried attempting this?
I have an idea. I haven't coded it up, but just I can share the idea.
Let's go for it. Do you want to share the screen?
I can just, you can work on that. I can just talk about it with this given example. Should be.
Yep. Let's do that. Go ahead.
Yeah. So I think the problem is O of n time complexity and O of 1 space, which is making it a bit complex. Otherwise, suppose if there was no space.
So yeah, leave the, generally in such things, like, this is the interviewer will not give you the time and space complexity expected. You're expected to do it in the most efficient way. So start with the brute force if at all. Then let's actually make sure that we have something that we can work with. So go on.
Sure. So one approach could be like, I can continue, like I can create an array and I can see what is the max I have seen so far towards my right, that kind of way. So at 1, 1 is the index, which is the max, and then 9 comes. So 9 is the biggest one, like, so far.
Mm-hmm.
Yeah, exactly. Max to my left and max to my right.
Don't do max.
Sorry, min to my right.
Or actually other way around, right? A max to my right and min to my left.
That's right. Yeah, we want to have a increasing sequence. So in this particular case, so 1, put to 1, 9, 8, 7, yeah, looks pretty good. 9, 8, 7, 10. So
max to my right is 10. In this case, max to my right is 10. I mean, it'll be 10 for everything.
Yeah, everything.
And min to my left is nothing.
Yes, from here onwards, it will be 1. And then we iterate one more time. And if anything is not my index and I have both left and right, then we have a solution.
These are the solutions, right?
Yes.
Pretty clever. I think this would work. We've seen similar questions. The room with the sunset view has a similar view. The other one is actually where you have the water, like the height of where you retain the water, right? If you fill a terrain, given all the heights of the bars, tell me how much water will be contained in that area. This is the approach that you use for that. Something similar to this approach. So I think fantastic. I think this approach actually would work. I don't see any concerns with this. It actually solves for the given specific problem. Like if you have an example of where it is instead of this, right?
Yeah.
If I had it as like essentially just a decreasing sequence, like, had this been 10 and has this been 1, then min to my left essentially will become, there's nothing here. This will be 10. This will be 9. This will be 8.
Right.
And this will be like,
I
this will
don't
be
think
7.
it'll be standard. Hello?
Go ahead.
I think at the index 2, it will be nothing there.
No, it will be minimum number that I have seen so far to my left. I'm not even looking at my number at this point.
Like and towards the left of index 2, the value 9, you have nothing there, right? Minimum to my left.
Minimum to my left is 10. 10 of all the numbers to my left, 10 is the minimum, right?
Yeah. At the index 1, you have the index 1, right? With value 9.
Index 1 is value 9, that is correct. Minimum to my left, not including me.
So that should be some value which isn't greater than 9, right? You shouldn't put.
No, you're not even looking at this number when you're doing that.
Okay.
You're just simply saying of all the elements to my left, what is the current value? Because the next iteration you can figure out, right? You need to make sure that minimum, me, and maximum are in increasing sequence. In this case, it's a no.
Okay, sure.
This is one way of doing it. I mean, you can actually cheat, or you can actually do this one step ahead and say that if the minimum value is more than me, then put a no. The problem with that is that not a big deal, because it should be fine. I don't think it's a problem, but I can see concerns with that. That it's just a mental model overall. So the other approach, which was actually suggested in case folks didn't catch that, was that instead of actually doing it this way, you would actually say that since the minimum to my left is still greater than me, I'm going to just ignore it and call it X, and just put X everywhere because it's not there.
Yeah.
Right. And in the same way, this also will be X's. So if all you have is a bunch of X's, then you don't have to. Then it just don't work. And in that case, in the third form of iteration, right, you really don't have to do. You don't have to do the A, B, C comparison. All you have to do is, like, as long as values exist in 1 and 2, you're good to go. Right.
Yeah.
So let me ask you, but I'm trying to change the question to see if I can trick you into using one versus other algorithm. One was saying that it's not monotonically increasing, like, equals are allowed, but not at both sides. So like 999 is not an increasing triplet. Okay. It can be either like a 899 or it can be a 9910. One of them has to be more. They cannot be all equal. So this is invalid. This is valid. And this is also valid. Right? So if I did this, then your algorithm will not work.
Yeah, unless I store index also of if I see the same elements, what was the min I have seen, maybe I need to store the pair also.
No, you don't need to store the pair. I think if you use the algorithm that you suggested, where you are actually putting the min to my left and max to my right as is.
Right. Yes.
Then what will happen is that then you will see 999 in the current location. In me will be 9, min max to the right will be 9, min to the left will be 9. Or in the other scenario, me will be 9, max to the right will be 9, and min to the left will be 9. So that will be 8. So you have all the three numbers. Whereas in the other approach, I didn't catch who said that, but in that approach, you would have X'd it out, or you would have put the value. In which case, if you put the value, then it's almost the same as what we have right now.
Yes, yes. I actually missed that. Since I am creating an array, I already have the index all the time, so I don't know.
Correct.
Yeah.
Fantastic. So this is actually a pretty straightforward, which is why I was like, no, the question is, I think I know why this question is a medium in that case, right? There are like there are two aspects to a question usually. There is a problem solving element to it, like how complicated it is, what kind of intuition do you need to solve it? And then there is a coding aspect of it. So this question coding will be super straightforward. You should be able to write like a quick for loop once, twice, and thrice, and you're done. Right? The first time the for loop you'll iterate from the right to do the max to my right. Then you will do a next one from max to my left. These are all O of n passes. And then the third one would be an iteration over these three arrays, essentially the base array and the new arrays that you've created. And that will essentially work, right? Now this is still O of n time complexity, and the space is still O of n because you're using an array.
Right.
Okay, and the thing is that this also will give you some ways of actually, you can actually find out how many such pairs exist to some extent based on this. Not all combinations, but at least you know that how many middle elements exist can be found out like this. And that's not required here. Your goal is actually to find the, you're just trying to find this. You're just trying to find if this sequence exists or not.
Mm-hmm.
So any other approach?
I have two more actually. Just when I was talking to you, one is worse complexity than this. Like convert this problem to longest increasing subsequence, which we have solved 100 times already. But the problem is again like it's not O of n even. It's maybe O of n square or n log n. And then
why is longest increasing subsequence n log n?
There are some smarter ways to solve it, I guess.
No, it's n log n because you're looking at the longest sequence, right? The sequence could be as long as half of the array or something like that.
Yeah, something like that. I haven't solved
what if I limit that to 3?
So
like the moment you find a subsequence which is longer than 3, then you're done, right?
Right. But you still create the O of n length of your DP array, right? If we are using that approach. I mean, I'm going into the implementation details. Maybe I shouldn't go there, but it takes like I will go ahead and I will check back. Hey, is there anyone who has less value than me? And I continue to do that, as my index goes towards right, I look back to all my previous elements. Wouldn't that be worse than O of n? It has to be worse than O of n. I think it will be O of n squared with my approach.
So let me ask you maybe a different question. Like, what if I said just find 2 elements, not 3, not increasing subsequence, but just like increasing doubles? How would you do it?
I will find min and max from beginning to end, and
you're done, right?
Yeah.
Just find the min, just find the max. But the problem is that min and max may be inverted, but they may not be in the right location. Like this could be the max, this could be the min, but I could have a 4 and a 5.
Right.
So that's not the right approach. What else?
So in the beginning, 10 will be our max value, and when I see 4, then can I say it is the max or min? Towards right, I have to have max actually. So what decision I can make here? I can't make any decision, so I will keep 4 as my max actually here.
4, why is 4 max? Your 10 is the max, right? Why is 4 max? So here's what it is, right? So let's look at this. Let's actually keep a number called small, and let's keep a number called large, okay? So first small is maxint, large is also maxint, okay? Now you got 10. So what is small, what is large?
Both are.
10 is a small. That's it. Only one number. Put it in only one slot, right?
Okay.
Now what do you get?
4. So 4 is,
if I put 4, 4 is the smallest I got, right?
yeah,
So any answer with 10 should also work for an answer with 4, correct?
exactly. Yeah, that's the.
So then I replace, it's exactly what you said, but I'm just trying to make it a little bit more like, algorithmic so that it's easier to get to. Now, if I find 5, what do I do?
So we
I
can
put the-
have a value for large can be
I
5.
put it here and we got an answer,
Right.
right? So let me actually, just for giggles, let me add a 3 here. Okay.
Mhm.
So now we process the 3. So what do we do?
So now 3 could be our small because everything behind that is already bigger.
Yeah, anything which is a solution with 4 will be a solution with 3 as well.
Right.
Right? And there is no solution that can exist with 4 and 3 anyway, so you can kick the 4 out.
Yeah.
And then 3, 5 is the solution, you're good to go, right?
Mhm.
Now, can we try the same for this question with this as your array? Let's do small, medium, and large. And I'm going to call it maxint, maxint, and maxint. Okay?
Mhm.
So what's the first number I put in?
1.
1. Okay? Then what's the next one?
So 9 is bigger than, so,
So put 9 at M, right?
okay, yeah.
Because 9 is in between S and L, correct?
Mhm.
And then what about 8?
So 8, maybe make it medium again.
So 8 will replace 9. Because any solution that actually is from 1 and 1 9x,
Yeah.
1 8x will also work, right? So yeah, next what?
So now 7 is medium.
Uh-huh.
10 is bigger than medium, so we have got a solution here.
And we got a solution. So what's the big O of this?
It's O of n, like in terms of time, and O of 1 in terms of space, because we are only using 3 values.
Yep. Somebody was saying something. Go ahead.
Yeah, so I think this question required that we should solve with O of 1, right? Space.
Yeah, the answer specifically it said that. Like Puneet also mentioned that in the comments.
Yeah.
Saying that the question is specifically O of 1. So how would you do it? The doing it like in the super brute force way with like an n cube pass. For I is 1 to all the way. For j from I plus 1 to n, from k to I plus j plus 1 to n, will give you an n cube solution. That's like a brute force. It will work, but that's not the requirement.
Yeah.
Then doing it the other way, which is like, max from the left, max from the min from the left, max from the right, is also another solution which actually works. But that is the O of n space. We talked about that as well. Now this is the approach which actually is like, that's why I was like, we are arriving at that. I think more than knowing the answer, we need to figure out how can we do better than that.
Yeah.
This builds the intuition for us, right? We are trying to essentially keep some sort of like a temporary placeholder for these 3 values and keep replacing them.
Yeah, this is pretty much.
Hi.
I think.
Can we try Hello? different input to see if it works?
Yeah, let's figure it out, right? Are we right? So let's go. Let's use this input, which is 1, 2, 3, 4, 5. That's actually pretty straightforward, because what will happen is you start with maxint, maxint, and maxint first. Then the first value will be 1 will be replaced with this. Then the second value 2 will be replaced with this. The third value 3 will be replaced with this, and we're done. You got that?
Okay,
So you can return to it.
I think, so just thinking of the way that you describe the solution using small, medium, and large, right? It looks like a monotonic stack of size 3. So I think this problem can be solved using monotonic stack of size 3. So it will still be constant space and linear.
Help me with the monotonic stack, definition. Does it not let you put a smaller number on it, or does it not?
So
what does it do?
What he's
Before,
saying.
Yeah, go ahead.
So what he's saying, like in your previous example, if you can put that one, we can go through that. I was also thinking about the same idea.
What I wanted to hear was like, I am not familiar with a monotonic stack. So just differ, right? Speak out the definition of what a monotonic stack is. Like, how does the data structure work?
I mean, yeah, so it depends on, so here, if you just want strictly increasing 3 numbers, well, you have to maintain the condition that every next number that you add in the stack will be greater than the number on the top of the stack. So whenever you have in your linear traversal, when you have the current number, we can check if the stack is empty. This is our first number, right? So I think we can just add it to the stack. But if it's not empty, if the number is smaller than the number on the stack, everything on the stack you can just ignore, because there is no sequence starting with those numbers. So now you're going to start a new sequence with the current number. So you add the current number to the stack. But
so that I like what you're saying. So let me actually just make it, because the thing is that you do change things that you're replacing with at different points of time, right? So an example would be that like in this case, right? So you could have an example of it where it's 1, then a 7. So 1 and 7 go into the stack, right? But the actual answer involves something like, you know, maybe not use a 1. Let me use a 5 and a 7. So that way, this is what happens. Then I may actually have a 1, 2, and a 3.
Right.
Okay. So if you do a monotonic stack right now, after the 7, the 1 will be ignored, right?
No. When you see 1, you have to ignore 5 and 7.
Oh, so which means you flush the stack and you put it back in, is it?
Yeah, because now there's no answer starting with 5 and 7. So you're
so tell me more.
This is the problem. Yeah.
So Vivek, actually start from the back. So in this particular
it's not working. Yeah.
Put 8.
The answer is symmetrical. So whether you start from the front or the back shouldn't make a difference actually. Whatever you just said will have the exact same problem with the reverse.
Please wait for a minute. Like you put 8 in the stack, and then you see 1.
So where do I put 8? In the large in this case?
Like it's your stack, so push on the stack wherever you want. Because now we are
with the count. Conceptually, okay. So let me put it there. I don't understand what your whether 8 is the smallest or largest. Do I push the 1 or not?
So 1 you are not putting, because you are looking at the stack and you know that actually 1 is smaller than 8. So actually you are going to push 1. Yeah, go and push 1.
Okay. So what you so in effect this is your L, but go on.
Then you see 7, and then you know that hey, 1 is smaller than 7. So well, just remove 1. But don't
give me 1 second. I know this will work. So let me just replace this for you. All I have to do is just flip this array into a different example of where I have to just essentially say that so this becomes a 1. This becomes a 2. This becomes a 9. This becomes a 3, and this remains a 5. So I'm going to do 2, 9. 3 and 5. Okay.
Okay.
So tell me what you do. So you push 5 first.
Yes, push 5 first. Then 3.
Then
3 is still smaller, so push 3 also. And then 9 is bigger than both of them. So both are like we will push 9, but we will replace all those guys. And then 2 is smaller, so we will push 2. So we don't have a solution in this particular case.
We do 5, 3, 2 as an answer.
Okay, that's the answer.
It's the same thing. I just mirrored it. I just like did a 10 minus that number, and I just flipped the stack. That's all. How I constructed the second one is essentially every number is like 10 minus whatever the number was, and I just flipped it. So that's why 8 became 2, 5 became 5, 7 became 3, 9 became 1. That's it. So you flip the algorithm, but that actually solves for that particular issue. It doesn't solve for the generic case.
Interesting. Yeah, I will have to look into it.
And the space also going up too, right? If you use the
no, it doesn't.
stack.
It doesn't. It's the stack is O of 1 space because the stack is limited to a size of 3 at most. The moment the stack is 3 elements, you have the answer.
Okay.
Right. So the reason why I don't think it's monotonic increasing. Let's solve both of these questions using the small, medium, large that we talked about, right? So what we do is we put 5 in this thing first, then we put 7 in this next. Okay. And then so what we now know is that if there is any answer that's more than 7, that'll work. and we are making an assumption that there is no answer that begins with 1. So let me flip this question. If this had been, this is the alternate reality, right? So at this point, I can't ignore the 1 because I've only seen 5 and 7.
Yeah, go ahead, Vivek. Yeah.
Right? So I don't think this approach works at this point, right? Because at this point, I really should have, what I should have done is I should have flushed the 5 and 7, made it this. This is like the monotonically increasing stack concept that you talked about. If I did that, then it actually fails for scenario A. But if I didn't do that, then it will fail for scenario B. So far with me?
Yeah.
Yeah, yeah.
Hello.
Hey, Sonia, go ahead.
So what I was thinking of it like if we know that we are getting small and we already got small and medium, and rest talking about the if the number is not less than that, then the else would be our answer, like true, because if it is not in a small and medium range, and then it should be greater than that number, then it will be returning that true value, like it's an answer. Because like if we are saying that if it would be replacing the, if we are saying that 1 is also there, it will replace that small with smaller 5 with 1, and again 8 would be there, and 8 will take the place of medium, then it will not be an answer. Sorry, 8 will replace to the large variable. But if we don't take a large variable only, like just take a small and medium, and if we got that 5 and 7, and like just 5 and 7, and
We lost you.
can you hear me?
Yeah, now we can.
Okay. So like if we replace 1 to 5, because either 1 would work or 5 would work, but we are ignoring the 1. So if another next one would be 8 is coming, then we know that we are having a variable, we are having that number which is not in small and not in medium. So it is greater than that, then it's an answer. Just return that.
So we have processed the 5, we have put the 5 in small, we have processed the 7, we have put the 7 in medium right now, okay?
Yes.
Now I get the 1. What do I do with the 1?
So 1 ultimately would replace the 5 based on this question, but it either would, it can start with 1 also, like it should not start with 1, but we know that 5 was there. So if for example, if the questions were only 5, 7, 1, then it's not an answer, because we are not having a third number, but we are having a third number which is greater than that 2 numbers. Then we know that it is an answer. We simply just return the true.
Got it.
Yeah.
Clever. I like it. Thank you. So just kind of like, so let me back up a bit and re-explain this algorithm. The way we do it is that we have like a small and a medium. We will not have a large at all in this case. We won't store the large. So what we will do is that both of them start with like, max int to begin with. Then when I find the first number, I put the small number here. The next larger number I find to the right, I'll put it here. So if I had like for whatever it is worth, if it was like a 957, right? Then I will start with a 9 here and a max int. Then the next step would be like a 5 and a max int. So far, that's what I will do. Then I will put a 7 here. Now the fact that I get a 1, right? So what I do is that I will replace the small number with a 1 at this point of time right away. The idea here is that anything that was an answer with a 5 and a 7 is technically the answer with a 1 and a 7 as well. So we don't have to worry about it. Okay, we are just returning true and a false. We are not returning what the actual triplet was. Okay, then when I find a 8, And since I have like 1, 7 and 8 is more than 7, I have an answer. Even though the reality for A, the reality was that it's actually 5, 7, 8. This will say it's 1, 7, 8 for all practical purposes, but still it found the answer. Now, if I find a 2, then what I will do is that anything that was an answer for a 5 and a 7 would also be an answer for 1 and 2, so I will replace this. So when I find a 3, I will say that I found the answer 1, 2, 3. So that is the trick that actually helps you get both A and B. That's why the monotonic stack piece is not, like we did the monotonic stack first, equivalent of that manually, but there is a trick to it where we are trying to replace the smaller element with the number. Is that what you're saying, Sonia?
Yeah, exactly this one I'm thinking.
I have a question.
Yeah.
In
Go ahead,
the
Smita.
case, you said that the small was 5. Sorry, the small became 1 and the medium was 7. In that case, we are not following the order. It is 7, 1, 8, right?
No, you're not. That's what I'm saying. So it's not like 7, 1, 8. Whatever is the answer for 5, 7, 8, we just have to return true or false.
Right.
Right. So this is not saying that 7, 1, 8 is the answer. All it's saying is that an answer exists. Because what we did was that we found the number 1, which was to the right of 7. And what we did was we replaced the small number with it just because. That's it.
Okay.
There's no specific concept around it, because you need to find a way to keep track of the small number without, I mean, you don't need anything that is an answer with 5, 7, 8 will also be an answer with 1, 7, 8, right?
Right.
I mean, 5, 7 and foo, if that was an answer, then 1, 7, foo will also work. So if you find that foo at a later point of time, the fact that S was 1, M was 7, and you found a foo, if it's true, then 5, 7 and foo will also be true, right?
Yeah.
Because the comparison is only with 7, not with the 1.
That's right. Okay.
The reason why you have the 1 in place is because you're trying to catch the 1, 2, 3 scenario.
Yeah, that makes sense.
Okay. In the same vein, if I just to kind of make it better or something, if I had this as like a 6, that will still work, right? If I had 1, 6, 7, right? If I had this, then this will become 1, this will become 6, and then when I process the last 7, I have an answer.
Yes.
You wouldn't know what the answer is. So it's a pretty. Now I'm questioning why is it a medium and not a hard, because it actually requires some special munging of the data, and I don't know if there's any intuition that actually gets me to this point.
So I have one question about this. Is it but it can be a version. So if we have to return the 3 numbers, this approach would work over there? I don't think so.
No, this approach will not work if you have to return the 3 numbers, because specifically in scenario A that I talked about above, right? It will return 1. It will have 1, 7, and 8 as your answers. So the way I would do this is that once I find out the number, I will actually iterate over the array from the right and find these 2 numbers. Like I know the M has not changed, the only S has changed, right?
Can you repeat that?
I have only overwritten the S. I have not overwritten the M.
Yes.
So once I find the answer, I'll have to go back in the array. I know where I stopped. I know where 8 was, correct? Then I go left, find a 7, and then I go left and find a number that's less than 7. I am guaranteed to find one.
Oh yeah, then this would work. Yes.
So if the answer was to find the actual, print 5, 7, 8, if that was the answer expected result, then you will be able to do that by actually going leftwards and figuring it out. So it makes sense?
Yeah, totally. Thank you.
Interesting. It's a good question. I haven't solved this one before, and thank you, Sonia, for the tip. I think it was like a pretty clever idea. I think it's good for most of us. Probably haven't heard of this one before. All right. So I think we have only 7 minutes. So I think it's time to switch to the third question. This one's going to be a little hard question. So let's find out. Let it load. Why is Okay, so you guys are able to see my screen?
Yeah.
Okay, awesome. So any thoughts on this question? So the question is, you're given a string and you can represent it as a binary tree by partitioning into two empty, non-empty substrings. There are different ways to partition it, I assume. And then the idea is that to scramble it, we just choose any two non-leaf nodes and then swap its any non-leaf node and then swap its two children. So that way, if you have this example, then if you swap the G and R, then that essentially becomes the RG8. That's it, and then you're good to go. So what do you think? Was that Bhavesh? Go ahead.
It is even number. So when there's even number, right children will have more, right? That's how. I mean, right subtree will have one more than the left. Is that correct?
I don't think it's not a. It's just a binary tree. So I don't think it's a. I don't think it's just one possible representation. So you could actually have. I'm assuming you could have like a G on the left and RE80 on the right. It's not an evenly split tree.
How many ways you can swap it? I mean, given a tree, given a string.
So you can the process of scramble is actually given a string, you can convert it to a tree first, and then once you've converted to any tree, the tree can be essentially you can have a tree, like in this great example, you can have a tree that is this way, or it can have a tree which is like GR and a EAT, or you can do GRE and a AT, and you can do GREA and a T. These are all the tree possibilities. And once you've done this way, this can be like a R, E and a AT, or it can be R and a EAT, or it can be REA and a T, and so on. So you have to construct one of these trees first, and that is not given to you which tree they're constructing. And then what you're doing is that you're actually swapping nodes, the child nodes, in any number of order. Like you can just go ahead and swap multiple times, right? And once you do that, then RGTAE is a possibility because you have actually swapped R and G and A and T. No, you have actually swapped this with this, and you've also swapped A and T. So we've done 3 swaps. Is the question clear?
Yeah.
So it can be any tree. It can be any sort of tree, and clearly there is like no way you can make this. So if it, let's assume this was A, B, C, D, E, then there is no way you can actually swap it to get this. Like the one way to swap C and A, right? That's what you want, right? The one way to swap C and A would be to essentially have it this way, right? You have to have a tree that breaks it into A, B, C, and this. Only then C and A can be swapped. Actually, you can't swap C and A at all.
So, one thought is that we have to see where the trees partition at the first children, and then keep doing that basically same thing with the both child. So, for example, in this case, GREAT and RGEAT, right? So
RGTAE.
RGTAE. Okay. So let's take the first, saying that it is partition at first. Now, if we and so that is not possible, because if we see that, so the way to decide whether it is partition or not is basically see that all the child are covered, in both side, left side. So in this case, left
They're
has
not.
G and so not. So take one more basically, because you can partition at one point, right? The moment we get it, that is one possibility. I say. So
This is
here,
a possibility. It is possible that you could have a letter like this, right? So in which case the partition can be this way, or the partition can be this way.
But this is one possibility. Yes. Now,
Okay.
now you
So let's
you do
assume it's
that.
this.
Yeah. Then keep doing for the same thing. Keep doing for the left and right side separately. And if we can get at the end, then we can say that it is.
Perfect. Does that make sense to folks?
Yes.
Okay. So the way this the good idea, Bhavesh. I think it makes sense. So essentially the thing is that you first this is the candidate. You try to see if it's this one. It's not, because obviously this G it's not the same set. All right, good. Thank you for muting. So the second was this. The only challenge that you have is that if you have an X here at the same spot, right, then you do not know whether it's partitioned this way or it's partitioned this way, right? And I think you'll probably have to explore both in that case.
Yeah.
Right? You have to explore this option and this option. And I think it'll actually be, will the answer be the same in that case?
Yeah, I was thinking if we take both way, will it change or not?
No, it's not an X, right? What if it was like let's assume that it was like a ARG and ARG like this, and this was an A. Right? So it doesn't mean that it was like, it's not useless, right? So if it was like this, right? This and this can mean completely different things.
Yeah, but before that, we have a question for the first A also in this case.
As well, yeah, of course. No, let me just do this. Something like that, right?
Okay, yeah. So then it becomes the same thing. So basically, we are saying that we have partition at AGR, and then there is a A. Now,
or we could be partitioned at AGRA, and then it could be AGRA and EAT, or it could be AGR and AEAT.
Is it?
We don't know.
Can we say that we take it any side? It should be okay or no?
No, I don't think so. I think you'll have to do both.
So basically, to prove that, we have to get to an example where in one case it be left, one case it will be right.
Correct.
Because in this case,
so essentially what you're saying is that, like, this is what you're doing, right? And something like that is what you're trying to do.
Yeah.
Then you have an answer. Right?
Yeah, right.
This is essentially what you're trying to do. And then you're trying to go through all of it. So essentially, you're trying all the combinations and you're getting going. And actually, it's fine, right? Because the thing is that you would just store, it should be fine. You would just store this in, you'd memorize the values anyway. So I don't think you'll be doing duplicates.
Yeah.
I think I would just try both at this point and move on. Like, I don't have any intelligence around whether I should be able to do it or not. I can read the discussions to see if folks have actually, had a better thought. But this looks like a reasonable approach to start this question.
On line number 23, you say left set S1 equal right set S1.
Mm-hmm. Oh, sorry. Thank you. That's what I meant.
Okay.
This is when the partition exists, right? Like the example in this case, right? You can't partition at the great and this. You can't partition at a G, right? Because the left side is just G, the left side is just R, and they are not equal. Whereas this is a valid partition because this is RG and that's also like GR. If left set of S1 is equal to left set of S2, then it also automatically means that the right set of S1 is equal to right set of S2, because that will be the first thing that you will verify. Not set, but. Because if there are duplicates, then set will ignore them, right? So it's almost like all the elements in the left.
So we have to do right side also, right? Same thing.
They should match. If if you have to do the first thing, there is like if elements of 1 equal to elements of 2, if they're not, then the answer is no.
Oh, I see. So okay, now makes sense.
Right?
Okay.
That's the beginning condition, right? So that's the first one.
I see. Okay.
So if left elements are matching, then the right element should also match because it's just math. All right. So with that, I think we're going to park today's session because I think it's already like a little over. This question is actually pretty interesting. I haven't seen the previous one and this one. I know we took a little longer to solve the second question. This question seems a little bit more tractable actually to me. Please do solve, write the code up and then post it for others to see. You can always go through the discussions that is there in the lead code. They actually have people who have actually solved it, provide questions, provide answers and whatnot. I think the interesting thing for you to do is make sure that you are following, build that intuition first and then identify what it is. The goal here is to understand the problem solving approach as opposed to solving this one specific problem. So with that, I'll park here and I'll stop the recording.